Hello everyone, welcome to the AWS Lambda tutorial for beginners. In today's session, we will simplify the concept of AWS Lambda from layman's perspective. To make it easy and engaging, I'll take you through several intuitive examples as well. So by the end of this tutorial, you will not only have a solid grasp of AWS Lambda, but we will also understand and create our very first AWS Lambda function together. But before we start, don't forget to click the subscribe button and hit the bell icon on the Intellipaat's YouTube channel, so you never miss out on more videos like this one. What exactly is AWS Lambda? Let's begin by understanding the problem AWS Lambda was designed to solve with the help of a simple example. Suppose you run a newsletter website where users subscribe to receive updates. Now here, the challenge is this subscription request can come at any time and in any volume, what we call as varying volumes. Sometimes it's just handful of requests, while at other times it could peak up to hundreds and even thousands. Now, think about this. Can you manually handle each one of these requests? Of course not. Keeping track of such a process would require an entire team dedicated to this activity, and even then, it wouldn't be efficient or scalable. So, what if there was a smarter way? How about a system that automatically manages this request for you? As the moment a user clicks subscribe, they're instantly added to your database and a confirmation email is sent right away, without you even lifting a finger. This kind of automation ensures that no matter how many users subscribe at once, everything happens seamlessly and in real time, making your workflow both efficient and scalable. That's where AWS Lambda steps in, which is a serverless computing service built on function as a service, that is FaaS model. But what exactly is serverless computing, right? In simple terms, it means AWS taking care of all the server related tasks for you, like provisioning, scaling and maintaining the underlying infrastructure. So you can focus solely on your code and functionality of your application, whereas in the traditional server-based models where a server had to be continuously running and maintained. But in Lambda, there's no need to worry about such managing servers or CPUs. AWS handles all of it behind the scenes, enabling you to build efficient and scalable solutions with minimal overhead. Now, coming to the FaaS model, here you can write small focused programs called as functions that can handle specific tasks that they are designed to handle. These functions are event driven, meaning they only run when triggered, ensuring that you only pay for the time your function actually runs. This process can significantly reduce costs because you are built only for the actual execution of your code, measured down to the milliseconds, rather than paying for an idle server as the traditional server-based models are. This pay-as-you-go model ensures you only pay for the charges for what you use, making it both cost-effective as well as efficient for handling workloads with variable or unpredictable demands, supporting the quick deployments, making it highly proficient for a wide range of applications. Now here's the cool part. Unlike the environments like VS Code, where you manually run your code with all those configurations, with AWS Lambda, the code runs automatically in response to the specific triggers that you have mentioned. For example, a user clicks the subscribe button or someone uploads a file. It can be anything. These triggers are called events, and they tell the Lambda exactly when to execute your function. Now that we have covered what AWS is and its core concepts, let's break down what are those tangible features that make it such a versatile solution for developers and businesses alike. So here's what makes it stands out. First is event-driven execution. Lambda functions are triggered by specific events, whether it's a file upload, an HTTP request, or a database change. This allows the real-time dynamic execution based on actual user or systematic actions. Second is language support. It supports multiple programming languages including Python, Node.js, Java, Go, and many more, giving developers the flexibility to work with the languages they are most comfortable with. Coming to the third point, that is automatic scaling. It automatically scales the number of functions instances based on the demand, Whether it's handling a few requests or thousands, Lambda adjusts seamlessly and effortlessly. Coming to the fourth point, that is monitoring and logging. With Lambda, you get the built-in integration with AWS CloudWatch, which provides real-time monitoring, logging, and the performance tracking, which makes troubleshooting and the optimization much more easier. Now the fifth point is concurrency control. It allows you to manage how much instances and how many instances of your function can run simultaneously, helping you avoid overloading your systems and ensuring a smooth performance during high demand periods too. Now coming to the last point, that is versioning. It simply means being able to manage different versions of your functions simultaneously. You can safely deploy new versions while keeping the older ones active, ensuring the smooth transition and minimizing the downtime. So up till now, we have covered what Lambda is and its key features. Now let's put this knowledge into the practice by creating our very first Lambda function from scratch. Okay, so up till now we have covered what Lambda is and its key features. Now let's put this knowledge into practice by creating our very first Lambda function from scratch and with a simple project. So for that, let's get an idea of what we are going to do here. As mentioned at the beginning of the session, we have discussed an example, right? So just aligning to that, we will see how to set up a Lambda function that captures users' data and sends a welcome email seamlessly, efficiently, and without any need to manage servers. We will also integrate DynamoDB for data storage and ensure everything runs smoothly with AWS services. By the end of this video, you will understand how to create and configure a serverless Lambda function, use API gateway to trigger the function, store data into the DynamoDB, and automatically send an email using AWS SES to the user's email ID. Moving forward, let's take a look at the flow that we will implement in this project. So the flow is, when a user submits the details on the website with the help of the front end, the API gateway triggers our Lambda function. Then the function stores the data into the DynamoDB and sends a welcome email using AWS SES. As you can see, the services we have used in this project are, first is S3, that is S3 bucket, which is used for storage, which helps to host our static front end. Next is API gateway, which will help us connect our front end to the back end with the HTTP endpoint. Then DynamoDB, which is a NoSQL database used to store the user's details received from the front end. Then comes the IAM, that is Identity and Access Management, which is used to create IAM roles to make sure that all the integrated services with Lambda are secure by giving them only required permissions. Then comes the heart of our backend, that is AWS Lambda, which handles the backend logic functionalities without the need to manage any kind of servers. And the last one is SES, that is Simple Email Service, which can send the welcome email to the subscribers. Now, the architecture leverages AWS services including S3, API Gateway, Lambda, DynamoDB, and SES to create an efficient, scalable, and event-driven solution. Alright, now let's begin with our use case. Beginning with the project, our front end is hosted on Amazon S3 as a static website. It provides travel newsletter preview along with the simple subscription form where users can enter their name and email. To test this, I have already deployed the HTML and JavaScript as an index.html file to S3 bucket. Let me show you how it looks in the action. So let me take you to the S3. Now these are our buckets, and the bucket we have used here is this my newsletter website, and from that you can see these are all the required files for our front end. And the main thing here is this index.html. Make sure you name the index.html file as your main file, because this is the thing that is going to render you as your front end. Okay? Alright, let me show you how it looks in the action. So this is the URL for the hosted website. Now let's take you to the URL. Okay, so this is how our URL of the front end looks like. Front end. So here you can enter your name, email, click subscribe, and here it is. The alert message is displayed here that says subscription successful. It means everything working fine, right? Now if you click on the OK, here it is. Welcome dear subscriber and thank you for subscribing us. So this is what it says. So tell me, do you like the front end? And let's get to the back end now. Also, all the files you are going to require for the front end are already uploaded on the GitHub repo and the link is mentioned into the description. So moving to the back end, we will begin with configuring IAM roles first, as our Lambda function needs permission to access and perform operations on DynamoDB and our SES, that is simple email service for that. Now this is IAM, you can search here for that as well. Like if you search, it arrives here. Exactly. This is what we are going to require here. Then go on the roles, create role, make sure that the use case you select should be Lambda and let this thing be default. Now move next here. So what is the permission policies here? The permission policies here basically tells you like what kind of role you want to assign to your function. I mean like what kind of services you want, what kind of permissions they should be having. So all that you can configure here. For now we are going to use Amazon SES full access. Exactly this one. Next is Amazon DynamoDB full access. Here. Also will require Lambda execution. Yeah. AWS basic execution rule. This is also a requirement. Okay, since we have selected our necessary permissions, moving next. Now name it as anything. For now I will name it as Lambda or SES DynamoDB full access. Lambda. Alright, these are our three main permission policies that we are going to use in this video. And for the function, now let's create the rule. So here it is. Now let me search SES Lambda DynamoDB. Yeah, so here it is. So our rule is ready here. Now let's go to the identities. So this is an Amazon SEO service, that is you can search here and you will get it. Exactly, Amazon simple email service. And this is identities. From here you can send and receive the emails of only and only verified email addresses. Now let's create an identity. Select email address. This should be the email address that you are going to send your emails from, like the sender's email address. For now I will name it as example.com or example@gmail.com. Now create identity. So it says verification pending. Since you know that example@gmail.com doesn't exist, I've shown you basically for the understanding purpose. You can give your real email ID for the verification purpose so that it works just fine. Now let me show you once I refresh this. Yeah, here you can see this example@gmail.com says verification pending. But the email ID that I'm going to use for my purpose is this one. And it says verified. So it will just go fine. And these are the email addresses that I'm going to send the email for. The thing is, to send emails through Amazon SES, you need to verify your sender and receiver email address unless you move out of the sandbox environment. Since I'm just showing you how this thing works, I'm not going to use the production environment. But if you need to send emails without the need to verifying them, you can move yourself and the environment to production environment. Then it will have no limits as for the verified email addresses only. So you can see as per your need. Then since this email is verified that I'm going to need for myself, make sure that your also is verified. Now coming to the next thing, that is our database. So here it is. Let me take you to the dashboard, tables. So this is the database that I'm going to use. Let me show you how to create a new one. So let's name it as subscribers. Subscriber is fine. Now partition key should be email, since you are going to use the email as the main thing or main key here, because names can be same but email can't be, right? So then click on create table, keeping everything default. Now it will take some time to create, and here it is. This is the table that we have created just now. Okay, so the another thing that is, go here, go into the exports and streams, move to the last option, and you will see this DynamoDB stream details. Turn it on, click on the new image, which means that whenever a new item is inserted into your database, your Lambda function will get triggered and do the function that it is designed for. So turn on streams, and yeah, it says stream status is on. Now since our DynamoDB table is properly set, let's now go to the heart of our backend, that is Lambda function. So let's see how to create a Lambda function, and that too from scratch. Now coming to the dashboard, you can see there are 3 functions already working, but we have to create a new one. So for that, click on create function, select here as author from scratch. Now give our function name. So what function name should be given? For now I will give as serverless demo API, or serverless API demo will be good. API demo. Okay, what is runtime? So runtime is basically in which language, programming language you want to write your function is. And since we are going to write our Lambda function in Python, I'm going to select the latest version of Python runtime, that is 3.30. No matter which language you're going to use, always choose the latest version of your any programming language, because if you don't, it can create some errors, some bugs later. So make sure that you don't select any previous versions. Now for the default execution role. So what is execution role? Basically these are the roles that we have created previously, one as in IAM role that we have created, you remember? So we have created it previously, so we'll choose that existing role here, and that is this AWS DynamoDB full access for Lambda. Now create function. Great. So this is our function. Now let's test it to check whether the flow is working right or not. For that I'll name it as test event. Okay, we have to create one. So test event. Now save it and then run it. So from here you can run it, and it says succeeded, which means our function is working just fine. As for the check, now this isn't the actual code that we are going to run. Our actual code is different, but for that first we needed to check that our function is working fine or not. But before moving forward with our backend code, we need to configure our HTTP endpoint into the API gateway service. For that, let's set up our HTTP endpoint on API gateway, that is here. You can search for it as well, you will get it here. So coming to the APIs, these are the APIs, and the one I'm going to use is this one, and let me show you how to create it. So click on the REST API, build, and then click on the new API since we are creating a new one, and I'll name it as serverless demo API. Now endpoint type should be regional because we are going to use in a specific region. Also one more important thing, make sure that all the services that you have integrated in a project, that they are in the same region, because if it didn't, problems can arise. So So then we have created our API. Now it's time to create our resource. So what is resource? Resource is basically like from where you're going to fetch the data. And what is the resource? So that is the resource. And let's create one. Let it be as it is. Here name it as get data. Now CORS should be enabled, because if you didn't enable the CORS, the request is not able to fetch the response and send it to the backend, right? So click on create resource. Great. Now here create method, and the method we are going to use is post, since we are going to need the post requests. Now select this as default, that is integration type Lambda function. This is your region. Lambda proxy integration should be on. And from here, click the function that we have created just now. So it was serverless API demo, right? So after that, leave everything default and create method. So it has been created. Now another thing that we are going to do it again is click here, enable CORS. So why we have to do it again? Because sometimes it doesn't give all the permissions, but we need all the permissions to make the response and request, right? So click everything, save, and here, successfully enabled CORS. So everything is just fine. Now that our API configuration is done, let's deploy the API. For that, click on new stage, name it as dev, deploy. Okay, after deploying, you will get an URL here. This is very important URL, as this is going to be the endpoint for your front-end and back-end connection. So copy it and paste it somewhere safe. And this is what we are going to need to paste it in our front-end. Let me show you. So this is our front-end code, an index.html file basically, and here into the fetch bracket we have to paste. So that was my previous API that I created. For the API that we have created just now, paste it here and give the resource path. This is very important. If you didn't give the resource path, the CORS policy will block the request, so you can't get the data from front end to the back end. Alright, and your request will not be processed. So our resource name was get data, save it, and this file should be uploaded to your S3. Make sure to you check it once and change this API, because my API is not going to work for you. You have to create your own API. Alright, so moving forward, now that we have created our API gateway. So before moving forward, let me tell you what API gateway actually is. It serves as a bridge between the front end and back end. By exposing the get data endpoint that we have created just now, like here you can see, this is our resource, right? So this is our endpoint, which triggers the Lambda function whenever a post request is made. Post as for the method we have created earlier. As we have already enabled CORS to allow request from the S3 hosted website, everything should work just fine. Now that we have configured everything required for the Lambda function, let's write the code for the function. And the code you need here is again already uploaded on the GitHub link. So coming to the serverless, Lambda function, select all, delete it, go to the GitHub repo, then click on the Lambda function, copy all the code. I'll explain you, don't worry. Yeah, and paste it here and save. Click on deploy. Okay, so let me tell you how this code works in the backend so that you can able to understand it better. So let's understand what Lambda is. So in Lambda, we have basically imported 3 Python libraries that are JSON, Boto3 and Dym. So what are they? JSON is used for parsing and generating JSON data, while Boto3, that is AWS SDK, is used for interacting Python with AWS services. And third is Dym, which is used to get the current time for logging subscription timestamps. And now coming to the next part, that is initializing DynamoDB and SES client. So DynamoDB here is used as an object to fetch the resource from the DynamoDB, and SES is also for the same purpose. SES sets up a client for SES in a specified region. For now, we have used is AP South 1, that is Asia Pacific, Mumbai. Now next is the stable object, which fetches the table in the DynamoDB that we have created earlier, that was subscribers, right? So make sure that you change this region, like whichever region we have created our SES, that should be the region name here. And for the subscribers, make sure that whatever table name you have given in your database, that should be exact same with this. Otherwise, it is not able to connect with it. Alright? Now moving forward, let's get to our first function, that is send welcome email. So basically it is used to send a welcome email to the subscriber using AWS services. From that, which uses SES, that is simple email services. As you can see, there are two parameters, that is email and name, which is similar to the front-end input details that we have mentioned earlier. As you can see here, it says name and email, only that is required. So same way, a function is designed with it. And this is the resource, like from where the email is going to be sent, like sender's email. So this should be replaced by your own email address that you're going to send your emails from. And destination, these are the addresses that your email ID will get from the database. Okay. Coming to the next function, that is save subscriber. It basically processes subscriber data, saves it to the DynamoDB and sends the welcome email. As you can see, it also has two parameters, email and name. Fetch the data and save it into the DynamoDB database. You can also see that it also returns the responses, whether it's a subscription successful message or failed to save subscriber message, so that it is easier to debug and see where our function is failing. And the last one is Lambda handler. So Lambda handler is the most important function here, which is an entry point for your Lambda function. It handles the incoming event from the API gateway and calls the save subscriber function. So without that, your code is going to crash. So remember, you do modify this as well if required. Okay, so this was our Lambda function code. Now coming to our serverless, let me add triggers so that where the things are going to get triggered out. So for API gateway, use an existing API, that is serverless newsletter API. For me, it was that one. You can use your own created version. Deployment stage was dev. And the security should be open, because if you click on the IAM, you have to configure all the roles over again. Open, it basically has no any security things, so it just works fine. Now click on add, and here it says the trigger successfully added. Now another is a database, from where the data is going to come. So click here, select on it. The table we are going to use is subscribers. Enable metrics so you can watch the logs and metrics on the CloudWatch. Leave everything default, select on add. And here, DynamoDB and API gateway are successfully configured as triggers. You can see it here, right? So this was our code. And now let's test it. For that, create new event. Mention here as event test. And now replace this with our main email body. Alright, so let's check whether it works fine or not. And also, again I'm telling you, make sure the emails that you're going to send the email to must be verified. And if you want to send email to any email address, you have to move from sandbox environment to the production environment in SES service. Alright? Okay. So now let's move forward. Save it. Test it. Great, it worked just fine. subscription successful for Sona Dukan. Okay, that means email is also sent. Yeah, here you can see the email is sent to my email ID. It means that everything is working just fine. Now let's check our database. So explore items, click here. Yeah, okay, let's check it again by deleting it. Since I have a very less verified email addresses, thus let's check it again. Test. Okay, executed 1 second ago. It's the recent one. Subscription successful for my name, and the email is sent as well. You can see here. Now let's check the database. Okay, refresh it. Yeah, it has been successfully here. See this. Now let's check my email ID. Coming here. Here you can see it. It was just 1 minute ago and it was just a second ago. Click here. It says, thank you for subscribing to our newsletter. Stay tuned for updates and special offers. Alright, so let's move back to our function. And it seems everything is working just fine. So this is how DynamoDB and API Gateway triggers our Lambda function to work independently and send the email to the verified email addresses that it receives from the database. Alright, and that wraps this tutorial. We have successfully built and executed a serverless newsletter subscription project. Thank you for watching and feel free to leave your questions in the comments. Don't forget to like, share and subscribe for more tutorials like this one. Thank you.